Okay, the main use of the theorem that we're talking about is you're given a vector field and you want to find the line integral of that vector field, but you don't know whether or not that vector field is a gradient of some function. And that's what we're going to talk about in this video. So let f be a nice function. Recall that fxy is equal to fyx. This is just Clairault's theorem. Okay, so if big F is a vector field in 2 dimensions and the components are g and h, and that's equal to the gradient of f, then what this means is that the derivative of g with respect to y is equal to the derivative of h with respect to x. That's just by Clairault's theorem. Because if gh is equal to the gradient of f, that means g is equal to the derivative of f with respect to x, and h is the derivative of f with respect to y. And so by Clairault's theorem, what we're saying is gy is equal to hx. And so let me just write this. This is because g is equal to fx and h is equal to fy. So gy is equal to fxy, hx is equal to fyx. Since these two things are equal, it means that those two things have to be equal. Okay, so the question is, can we turn this around? In other words, if we know if f is equal to gh and gy is equal to hx, is there a function that satisfies f sub x is equal to g and f sub y is equal to h? In other words, if we know that gy is equal to hx, is f a gradient field? Is it the gradient of some scalar valued function? Okay, so for nice functions, this is true. And what the theorem says is that if we have a vector field f and its components are g and h, then f is equal to the gradient of f for some nice function f, if and only if the y derivative of g is equal to the x derivative of h. And we're going to prove this in the next video, but this is an incredibly useful theorem. Let's look at the example that we just did. Notice the derivative of 2x with respect to y is equal to 0, and the derivative of 2y with respect to x is equal to 0. So this satisfies the theorem here, and so there is some function such that 2x, 2y is equal to the gradient of some other function. It is equal to the gradient of that function, which is what we use to solve the problem. In the next video, we're going to prove this theorem.